processor has a von Neumann architecture. True or false?
True.
False. You guys haven't been reading your book. What does it have? Who knows?
Harvard.
It has a Harvard architecture. What's the difference between a Harvard architecture and a von Neumann architecture? A Harvard has multiple buses, just in general, and a von Neumann has one unified bus. Okay? Alright. The reset vector stores the address of the routine which executes when the power on or reset button is pressed. True or false? True. Okay. Everyone gets that? Quiz on it in lab multiple times, right? Alright, so this port GPIO port B data R refers to a blank that stores the current state of port B. What is it?
Register.
Is it a register in the CPU, a memory address in ROM, a memory address in RAM, or an external device address? Okay, so where is this located? It's actually located in approximately address like 4. It starts with a 4, right? It starts with a hex 4. Does everyone remember that? So on your sheets here, you're given this little memory map. So where does it exist? It exists in this space, so I/O ports, right? So that actually refers to a what? External device address. Right? Or wait, no, hold on. Yeah, external device address.
Wouldn't you have to first set it as a variable name instead of be stuck in ROM for?
So an EQU is actually not a variable. So when you do an EQU, it's a preprocessor directed, right? So what happens is it copy pastes it. So I have this GPIO, blah 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 blah, some address here, right? What it's gonna do is when I write my LDR R0 equals blah 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 or GPIO whatever, it's gonna copy paste this address into there. And you remember that's a PC relative operation, right? So what I'm really saying is that this is an address, right? This is an address, so it's going to go to this address and get something from there, right? Or actually, initially it loads that value directly in, but when we do that extra LDR, that's when we get it. So the question is kind of abstract, but it's really asking you what it's describing, and it's describing the data register for the external device.
Why is the answer not a register if it's the data register?
Well, because it's like, that's a good question. It's memory mapped I/O, right?
So it's acting like a register.
We just call it a register because external devices have I/O registers that like are separate. That's generally the way we say it. But since this has memory mapped I/O, it's a little different. It's just convention. Alright, so the ARM Cortex has 5 buses, right? On each bus, how many address lines are there? How many? That's 32.
One for each one.
Okay. How many data lines does it have? 8, right? Because each memory location is 8 bits. Wait.
16?
Actually, it might be. It's a good question. I put down 32. I'm not sure. Does anyone remember from class? I'm gonna go with 32. Yeah.
Nathan.
It has 32 address line for sure.
Google?
I tried to look it up last night, and I really don't know how many data lines it has. I just have no idea. And I like asked Paul Bono, and I don't know because he says he's over.
So he doesn't even know?
He probably doesn't. He knows it somewhere.
He's just trying to make you learn your lesson, I guess.
Somewhere on his website.
Finally, prescale computers use big endian versus Intel computers which use little endian. Fact.
Stupid website.
Therefore, the following byte represents the decimal value blank on presale computers. Basically, is this true or false? Anyone? So I have, someone says false. Why? Okay, so what does big endian mean? What does little endian mean? It means it reads them in different, like the memory space is read in a different direction, right? In a different order from bottom to top or top to bottom, right? Yeah. Or data is ordered from bottom to top or top to bottom. Okay? So this is a byte, right? So let's assume that a memory location at its smallest is 1 byte, right? Does that change anything for us? No. Right? That's the trick to this question. We don't even have to know how big the each memory location is. We just know it's a byte, and a byte is the smallest data value you can have. And so the only time big endian or little endian matters is when we have multiple bytes. Okay? Okay, cool. So that's all I have for this review. Does anyone want me to go over anything else? If not, I'm just gonna.
Oh, is that true?
Can you go over the address?
This is it won't be different. What'd you say? Can I go over what? Guys, quiet. The what? The new addressing modes you have? Yeah. So those are 3.3.2, right?